Hello there, and welcome everyone to our next webinar, which is going to be around the K-nearest neighbor classifier. My name is Jan-Willem Middelburg, and I'm going to be your host today in this 45 to 1 hour webinar, in which I'm going to take you on a deep dive into one of the most famous algorithms that is used within big data. Before we get started, just a couple of things around the logistics of this webinar. Because we have received over 150 registrations, you will see that everyone has been muted by default. If you would like to ask questions at any moment during the webinar, you can use the Q&A functionality, which you will see at the left-hand side of the screen. In case you do that, my screen will pop up and I will be able to moderate some of these questions. I will keep moderating the majority of the questions towards the end of the webinar in order to make sure that there is some level of conciseness and the storyline doesn't get interrupted too much. But please, by all means, feel free to ask questions. That's the whole benefit of doing an interactive session like this. The second key point around logistics is that note that this webinar is going to be recorded, including all of the questions that you might ask. As you will see a little bit later, I'm going to do a live demonstration of how the K-nearest neighbor classifier works in practice. I will distribute all of the source files as well as the scripts that I'm going to show after the session. So if you signed in, you will receive all of the materials that are showcased here today. So don't feel that you would need to copy and paste notes. I will share all of the source code as part of this webinar. First of all, thank you so much for joining today and taking an hour of your day to join in the session this morning. Good. Let me get started with giving you a brief introduction of our agenda today. What I typically do for these kinds of in-depth sessions is that I structure it into three main components. I'm going to get started with an introduction towards classification and clustering algorithms. And we're going to look at where the K-nearest neighbor classifier falls and how it's being used in practice. Secondly, I'm going to dive into the algorithm itself. We're going to go into the workings and the mathematical models that are being used in K-nearest neighbor. This will be a bit more of an in-depth explanation where I will go into some of the math around this classification algorithm. Last but not least, you will all obviously see this algorithm in practice. What I've done for today is that I prepared a case study there where you will see how this algorithm can be used. I will share my screen and we will run through some of the scripts that you can use in order to utilize this algorithm in real-life situations. So please feel free to follow along as we are progressing. And if you have any questions, either from a technical perspective or from a conceptual perspective, again, please feel free to put them into the Q&A box. Good. I'm going to get started with a short little introduction around why we're hosting these series of webinars and what the Enterprise Big Data Framework is, which is hosting this series of informative educational videos. The Enterprise Big Data Framework Alliance is an independent body of knowledge that is promoting the development and advancement of big data best practices. What we're aiming to accomplish is to create a community around enterprise big data and establish critical best practices that are relevant for any enterprise organization. What we're trying to do is to inspire, promote, and develop excellence across the globe by making sure that people have a better understanding around data analysis, machine learning, and artificial intelligence using corporate data. One of the main pillars of our alliance is that we're working in a vendor-neutral program. So you won't see any recommendations around specific technologies. Rather, we are focusing on the key concepts, the techniques, and the non-proprietary algorithms that everyone can use. As such, we have developed a whole curriculum of educational programs, and all of the underlying books and resources are free to download for everyone. What you will see is that today I'm going to be showcasing some of the materials which are part of the Enterprise Big Data Analyst book, which you see highlighted with the arrow on the right-hand side. This book is free of charge, so you can just go to the website and download this PDF and basically run through all of these steps by yourself. Why have we developed the framework? Well, we think that it's time for standardization and common best practices when it comes towards the field of big data. The main model of the Enterprise Big Data Framework is the one that you're seeing at the bottom of this slide, which showcases that organizations can build up capabilities within big data in 6 different domains. Today, one of those domains that we're going to dive into a little bit deeper is that of big data algorithms. And in this series of webinars, in which we're discussing different algorithms, we're going to give you more insights and an in-depth overview of what those algorithms are, but more importantly, how do they work and how can you apply them? So I hope you'll find these materials useful. Good. Today, what we're going to look at is a small and comprehensive subset of what is known as big data analysis. And to put things into the bigger perspective, I would like to start with this slide, which shows you the overall big data analysis process. Note that the algorithm that we're going to discuss today is a part of a larger ecosystem. And that ecosystem is depicted within the 5 different pillars that you're seeing right here. In any large organization, what you're going to be seeing is that analysis is working all the way from the objectives, what is it that we aim to achieve, towards the ingestion of data, preparation, analysis, and finally presentation. What you will see in the analysis column is that there are a set of variety of different algorithms that you can use in order to solve business problems. And within those different domains, there are again dozens of different algorithms that we can discuss. What we do in this big data webinar series is that we're every time picking out one of the different algorithms that we will discuss a little bit more in detail. And today's candidate is the K-nearest neighbor classification algorithm, which is one of my personal favorites. This is obviously a classifier and classification algorithm. So that's why you see that I highlighted the green box around classification. So you will be able to put it slightly more into the bigger picture. Good. Let me get started with a brief introduction to the concept of classification, because not all of you might be familiar with what classification is and how it's being used. Classification is a class of algorithms that is frequently used in data analysis and data mining. And the objective of classification is to identify and assign a known number of categories towards collections of data. One of the very famous examples that is always used to explain classification is with spam filters in email. Based on the email messages that you receive in your inbox, a spam filter will need to make a classification, whether it's a regular and valid email, or whether this email is considered spam and should go towards a different mailbox. This is a very simple, although it can become a very complicated form of classification, in which we are classifying into 2 different components. This is a concept that we are calling binary classification, where you just need to choose between 2 different categories. Classification in itself can go a couple of steps further. So we can also assign them to 5, 10, or maybe even 1,000 different classes. However, the key point to understand around classification is that those categories need to be determined upfront. So we will assign incoming data points towards known categories. And that's a very important element to understand around classification, because that means that before we run any type of classifier, you would need to specify what those outcome variables will be and which particular classes will be in existence. For that reason, we are referring towards classification as known classification or supervised learning. Classification algorithms, and there are dozens of different ones in the world, will all have different forms of specializations. And there's a variety of different mathematical techniques that you can use to use classification algorithms, like decision trees, linear programming, neural networks, and statistics. The one that we're going to use and see today, KNN, is more of an entry-level classification algorithm. And we will see that most of the algorithmic steps are used using basic mathematical calculations. Classification is extremely useful for a variety of different business cases. In a lot of classification elements, we would like to group elements towards specific known categories. Another very famous example is, for instance, classification, whether, for instance, loans or mortgages or any kind of applications will be valid. Classification algorithms can be used for that account. A more modern approach is to also use classification algorithms to do things like facial recognition or to automatically detect objects through phones. Those are obviously more in-depth classification algorithms, and I'm sure we will cover those in upcoming webinars. For this day, however, we're going to get started with some very basic classification, and we're going to get started with a simple classifier, which is the k-nearest neighbor classification algorithm. In order to understand a little bit deeper around classification and classifiers in general, note that any classification algorithm, because it's a form of supervised learner, will always consist of two steps. Any classification model will therefore need to go through those steps in detail. The first step is what is known as the learning step. And this is where we are training our classifier to make adequate decisions when confronted with choices. In the example that I mentioned earlier, when we talked about classification of emails, an example could be that we would first need to showcase which emails are considered spam versus which emails will be considered as valid and true messages. This learning step is crucial because if you don't do this, you cannot showcase or teach the algorithm to which categories it needs to assign unknown data points. Within big data and data science, we are referring to this as the training step. And you will see in a lot of data sets, including the demo that we're going to see today, is that a training set will be used for this learning step, for this learning process. After we have gone through this learning step, the next step is to see the classifier in action. And this is what we refer to as the classification step. This is where the model is used to use predictive classes and is going to actually classify data points that it hasn't seen before. Based on this classification step, we can make certain claims around how accurate our classifier is and whether there are any specific elements that we might improve towards the future. In the demo that I'm going to show you today, I'm also going to go and show you the accuracy of the model and what are some of the steps you could take in order to make it better. On the right-hand side of this slide, I've shown that there are a number of different classifiers that you can get started with. The first one, and the one that we're going to cover today, is the k-nearest neighbor classifier. But note that other very famous classifiers are naive Bayes, logistic regression, or classification trees. These other classifiers will be covered in other upcoming webinars. So if you're interested to learn about these as well, please join any of those upcoming sessions. Good. Today, we are going to narrow it down and keep our scope on the k-nearest neighbor algorithm. The k-nearest neighbor algorithm is probably one of the most basic and most frequently used algorithms for classification purposes. I personally am a big fan of this algorithm because of its simplicity. It's easy to understand, it's easy to explain, and it's also easy to use on a lot of large data sets. What you need to understand around k-nearest neighbor algorithms is that they are non-parametric approaches. And that means that the model structure is determined by the underlying data. So we don't need to set and optimize for parameters. The algorithm will work on any incoming data set as long as you've set it up correctly. This ensures that the KNN algorithm can be used in a wide variety of different situations, ranging from the classification of email spam to mortgage applications, and in more complex situations towards limited forms of facial recognition. The reason that the k-nearest neighbor algorithm is called this way is that it is going to look at its k number of nearest neighbors, and where k is going to be specified by us, by the data scientists that are setting up the algorithm. So k is the variable point within this algorithm. What we mean with nearest neighbors is the closest data points that are aligned towards this. And the way that I always like to explain this is think about similarities that you see in nature. For instance, if you have an orange which has the color orange, and you have an apple which has the color green, then the next time that a new fruit comes in, it is going to look at similarities and properties which is closest related to this. So for instance, if you will get a data set around, let's say, grapes, and you can only classify between orange and apples, because the grapes are green, it's more likely to classify it towards an apple. So that means that it's going to look at the closest similar data points that you have set up your classifier to look at. Obviously, in the k-nearest neighbor algorithm, there are a number of variables that we can specify, and that's what we're going to look at today. Let's dive a little bit deeper into the math that is empowering k-nearest neighbor algorithms. The k-nearest neighbor algorithm works on the basic mathematical function that you're seeing here on the slide, which is known as the Euclidean distance. The k-nearest neighbor algorithm calculates the distance from any new incoming data point towards all of the other closest data points that it is similar to. And out of all of these data points, it will select the smallest distance towards those other data points. Based on this distance, it is going to assign a specific class towards that data point. So to continue the same example that I used before, it's going to see that the color green from a grape is closest towards the color green from an apple. And because that distance from a mathematical perspective, and even in RGB colors, which is a little bit more of an advanced topic, because that similarity is closer, it is going to assign that towards the color green and therefore classify it as an apple. The Euclidean distance is not something scary or something new. Most of you will have seen this basic formula in high school, where the distance between P and Q is given as the sum of the distances in itself. So this is just basic triangle calculation. The KNN algorithm in its basic form uses the Euclidean distance to determine this distance. Note that in more advanced forms or advanced versions of the KNN algorithm, it's possible to set other ways of calculation or use other distance measures, but I'm going to leave that out of scope for today. The example that we're going to see today in the demonstration will use the Euclidean distance. So let's visualize this a little bit more in very simple terms. And in order to do this, I would like you to take a closer look at the picture that you see on the right-hand side of this slide. Suppose that in this very simple algorithm, we have a classification which is binary. And it means that we need to classify data points either towards class A, which is depicted in blue, or class B, which is depicted in purple. And note that each of those data points, blue and purple, so A and B, will just be given by two very basic variables, which are x1 and y1. So in the same example, we could say, for instance, if it would be the classification of fruit, we could use a color scale, and we could use, let's say, the size of the fruit, just to make it very simple analogy. The key question that this classification algorithm will need to determine is, for any new data point, will it be assigned towards class A, which is visualized in blue, or towards class B, which is visualized in purple. The way that we're going to do this is by looking at all of the closest data points towards the incoming data point. So we're going to be looking at its nearest neighbors. And that's obviously where the term KNN comes from. In this specific case, what we have set as a data scientist is that the variable K will be 3. So that means that we're going to be looking at the 3 closest data points compared towards the new data point. So in the picture on the right, consider the data point that is depicted in green. For this new incoming data point, we would like to determine whether that should be classified towards class A or towards class B. By using the K nearest neighbor algorithm, and where K is set towards the value of 3, we're going to be looking at the 3 closest data points. What you can see in this particular example is that the 3 closest data points is 1 point will be in purple, so class B, and 2 points will be set towards class A, which are in blue. What that ultimately means is that if we use this very basic classification algorithm, that the new incoming data point for a value K is 3 will be set towards blue. And this is, in a very simple nutshell, how the KNN algorithm works. What you will see by the blue lines on this slide is that the algorithm calculates the distance towards the closest data points, which is what you see depicted in the 3 lines. It will look at the value of those 3 closest sets, and then it will make a trade-off to classify the point to either A or B. And in this case, it's going to classify towards A. Whether or not the value is classified correctly or not is not something that you can immediately get out of this picture. Also note, and this is a very important thing to note around K nearest neighbor, is that the value of K will have a very strong impact on whether the point is going to be classified as blue or as purple. I will come back towards this a little bit more in detail later onwards. But the value of K is a variable that we can optimize in order to come towards the best classification model. And that's really something to take into the back of your mind. Good. Let's get moving on, because I also would like to cover some additional concepts before we're moving into the demonstration. One of the most obvious questions that you need to ask yourself as a data scientist is, if I'm applying the KNN algorithm, what would be the best value of K? Should I look towards the 3 closest data points, the 7, the 10, or maybe even the 100 closest data points? The best way to determine what the value of K is going to be through experimentation. And one of the critical jobs that you would need to do when you're optimizing or applying this algorithm is determine which value of K will have the highest accuracy, meaning that the number of data points classified by the classifier is going to be correct. And remember that this is a supervised training set, so we can very easily calculate the accuracy of our classifier because we have a test set available. So we can compare the accurate results versus the predicted results very easily. And we'll show you that in a second. If you run a number of these different simulations, what you will be able to see is what will be the optimal value for K. I'm going to show you that in the demo a little bit more in detail. Also note, and this is also a very important thing to get your head around, is that the number of variables under consideration is completely independent of the value of K. One of the things that I forgot to mention on the previous slide, so let me go back for a second, is that the number of variables that are part of the data set could be endless. Of course, there is a limit to that for practical reasons, but I will keep that out of scope for today. But what you're seeing on the bottom of this slide is that KNN can also be used for 3-dimensional models. where we have 3 different variables, and we can even use it for higher dimensional models. So the value of K is completely independent on the number of variables that you have in your data set. So if we talk about structured data, think about the different columns with different variables that you might have under consideration. So it's important to note that even though I explained it very graphically and visually, is that KNN is not limited towards 2 dimensions only. And it can calculate Euclidean distances in very similar ways into multiple dimensions, even the ones that we cannot visualize anymore. The other key point that I want to note up front is that KNN will have a significant impact on based upon normalization of data. For the people who are already a little bit experienced data scientists, will know what normalization is, but if you're completely new to this, think about normalization as aligning the variables of data. So what I just mentioned in this very simple example before, if you look at the 2 variables for the classification of fruits, think about color and think about size. Color will be probably in an RGB spectrum, which is mathematical. Let's say size will be in centimeters, millimeters, or even inches. So you see that within the same data sets that there will be completely different variables. And if you don't normalize your data, the fact that those dimensions can be significantly different can have a massive impact on the outcomes. So as we will see, and I will show you this in the demo as well, is that it is good practice to look at normalizing your data sets and normalizing your columns before you feed them into the algorithm itself. So normalization can help to overcome this problem, and we will see this in a second. Good. So far, what I covered in the first 20-25 minutes is the mathematical background around classification using the KNN classifier. I always think it's good to see this really in practice. So what I've done for today is prepared a very simple case study, and that is for the prediction of the quality of wine. And basically, you could use this for a variety of other different similar problems as well. And what we're going to be doing is that we're going to be looking at the ingredients which are on a bottle of wine, which are typically depicted on the label. And we will be using this classification algorithm to determine if a bottle of wine will have a high quality. So in other words, if we look at the label of a bottle of wine, let's say you go to your local grocers and you have a bottle of wine in your hand, based on this algorithm, could you predict what the quality of wine is just by looking at the label, and not with the text which says that it's obviously a great wine? So this is, of course, a very interesting problem. It can be used for a variety of different fields as well. And think, for instance, if you're a large retailer or you're a big grocer and you need to purchase significant amounts of products from different vendors, you could use this algorithm in order to optimize and to make sure that you can purchase wine consistently and learn in that process what will be the best bottles of wine to purchase for your customers and which bottles of wine people will likely appreciate and purchase again. So in this case study, we're going to be using a data set, and this data set will contain variables around different bottles of wine. So the variables that are available in this data set, and I will again share this data set with you after the webinar, is where we have variables like the type of wine, whether it's red or white, which is binary. We're going to have values for acidity, we're going to have values for sugar, we're going to have values for chloride, dioxide, density, pH, etc. So this is a wine set that is one of the open wine sets which is available, and that's what I built this demonstration around. Note that for consistency, because there's obviously a very big difference between red wine and white wine, is that in this particular demonstration, we're only going to look at the subset of red wines only in this particular example. So what I will do first is that I will talk you through the steps in which you can build this classification model. And then I'm going to show you this within an online programming environment. I will showcase today's example in our studio to kind of show you how it will work, but you could use the same in a Python script. It's actually very easy to also translate this into a Python script. So let's have a look first. The first thing that we need to do in setting up this problem is that we need to define what will be quality. So what we've done in the first step is that we're going to be adding quality labels towards this data set. And these quality labels can be based on history, can be based on surveys, can be based upon expert guidance. So we have different values for each bottle of wine, whether it's poor quality, which is rated 4 or 5, medium quality, meaning it's rated 6 or 7 in a survey, good quality, which is 8 or 9, or exceptional, which is rated as a 10. So the first step that we're going to be doing in our data set is that we're going to be adding these quality labels. And these are the 4 different classes that we would like to classify into. Remember that at the beginning, I told you that for classification algorithms, you always need to determine what will be the classes that we're assigning to. So here you can see that step. We're assigning 4 different labels towards bottles of wine. So poor, medium, good, or exceptional. Those are the quality labels. These are the categories that we're going to be using the classifier for. After that, we're going to start with our first step, and that is using the training of the KNN model. Now that we've added the 4 labels, we're going to be using a training set to show how to classify our list of red wines. And in order to do that very simple, we're going to be using the KNN function, which is part of the class package in R. So in case you are already a little bit familiar with R programming, it means that you would need to import the class library, and then you can find all the information around KNN with this question mark KNN command, and then it will show you all of the information around this particular algorithm. What we will see in this class package is that we will have a number of different variables, like the training and the test set, which I will obviously show you. We will also see the factor for true classifications, which is the CL1, and then obviously, as we've seen that our main variable is K, the last variable will be the number of neighbors that needs to be considered. So for people who are not familiar with classification algorithms so far, note that there's always a difference between a training and a test set. The training set is used to train the model, so it helps you to identify which classes should be assigned. And then with the test set, we can actually see whether or not that model is valid. So we can start to calculate accuracy, which I will show you in a second. Reason why this is done is that otherwise you might, if you just use one training set, you might over optimize that. And in data science, we refer to that you're introducing bias. I won't be going into that into too much detail because I would need more time in this webinar. But note that this 2-step process for classification always holds. So there's first a training stage, and then there is a test stage. Good. So that's the first step. Then the second step is that as soon as we've done that, we can now start running our KNN classifier. And what you could do just in order to get started is run it with a default value of K equals 1. So K equals 1 means that this is the default value. If you don't manually specify it, then it's just going to use the value of K is 1. And that means that we're going to be looking at what will be the accuracy of that particular model. Note that in the data set that I've been showcasing you is that you would need to eliminate variables, columns 1, 13, and 14, because they were not relevant variables. I will show you that in a second. So the very easy way that you could do this is you're just using the KNN pre-programmed algorithm that's there, and you're going to make predictions based on that training set, and then you will compare that with the predictions of the test set. And that will lead towards the model accuracy of this particular example. So accuracy is obviously the number of correct predictions over the total number of predictions. So if I classified a bottle of wine as being exceptional, is it really exceptional? Was there a stage in which people said, well, this was really an exceptional bottle of wine? So this model accuracy is, of course, tremendously important because it's going to showcase and it's going to tell you how well your algorithm has been designed and how well the steps are that you have taken in order to set it up. So the higher your accuracy, the better it's obviously going to be. And I always like the description that you see in the box on the right-hand side. The better a model can generalize unseen data, the better predictions and insights it can produce. And in the end, that obviously means that it provides more business value. If you're a purchaser of a big wine store and you can already predict, let's say with a 95% accuracy, that your customers are going to find this wine very good or even exceptional, then that might be a good sales result that you can get right away. So that's step number 2, predicting the results. In step number 3, we're then going to investigate and we're going to review how well our classification algorithm has been set up. So in this case, what we're going to be doing is we're going to set up a confusion matrix in which we're going to be plotting the predicted versions from the wine versus the test versions of the wine. And in the confusion matrix, you should always look at the diagonal line, because this is comparing the predicted class versus the actual class in the test set. So here in this particular example, you will see that the model that we've trained for a value of K is 1, and that's an important thing to note, is that for the good qualities of wine, there are actually, there were no bottles in the collection, and there were also no bottles classified as such. In the medium category, 203 bottles were categorized as medium, which were actually medium quality. So there was a significant amount that has been done correctly. And in the poor category, there's 133 bottles that were classified as poor and that were actually poor. However, if you look around that, you see that there's also a large number of misclassifications. So if you look at the values of 138 and 104, these were bottles that were either classified as poor but were actually medium, or bottles that were classified as medium but were actually of poor quality. So this is known as a confusion matrix. And based upon that, we can start to define what is the overall accuracy of all of our predictions. And the accuracy in very simple layman terms means what is the value of good classification, so everything that is in the diagonal, versus the total number of classifications, so all of the elements that are in this particular matrix. Good, I'll show you that in an example within a few seconds. So that's the first 3 steps to run through, so to get a bit of a better understanding of how your model works. What I already mentioned up front is that the value of K will obviously have a very significant impact towards the way that our classifier is going to be working. And in order to illustrate this, let's look at what will be the results for different values of K if we're using different sets. So for instance, here you see 3 different values of K. I've labeled them K9, K11, and K13. And that is where you can see that for, if you look at the 9 closest neighbors, that the accuracy will be around 0.59. But if you, for instance, would use K13, it already goes up towards 0.60, which is 60%. So that the whole model will become 1% more accurate if you're increasing K from 9 to 13. And that obviously brings in the question, what will be the most optimal value for K? And that is also, of course, something that you can simulate. So let's look at that a little bit more in detail. The last key part, before I'm going to dive into the live demonstration, has everything to do with normalization. And in order to illustrate that a little bit, let's look at one of the variables. So one of the variables is citric acid. And citric acid ranges on a scale from 0 to 1. So all of the values in the data set will be anywhere between 0 and 1. So 0.1, 0.2, etc. However, if you look at the variable of total sulfur dioxide, it ranges from 6 to 289. So if you just would use these two variables and you would plot them against each other, then the impact of total sulfur dioxide on your classification model will be more significant than citric acid. And in order to overcome this problem, it is good to use normalization. So one of the ways that you can easily do that is to normalize data. I'm not going to go into the normalization process into too much detail today, but normalization works with z-scores, and what you can do is you can normalize all of your data based back towards that range of 0 to 1. So in this case, it means that we're going to range back the data of total sulfur dioxide towards the same scale of citric acid. And that is what's going to make it very easy to do this. Both Python as well as R and any other programming language will have pre-built functions that allow normalization. So it's actually a very simple exercise to do. It's very easy to get started with doing that. But this also will have a significant impact on your normalization. So remember that in the previous slide, I showed you that with unnormalized data, the value for K13 is 0.6. If we were to normalize the data, you will immediately see that the accuracy is going to increase to 0.686. So there's almost a 9% difference whether you're using normalized data or not, which is very, very significant for these kinds of exercises. So normalization is also something that you would need to consider in using the KNN algorithm. So a couple of key things to learn around, and what I hopefully explained into a little bit more detail today, is that if you look at KNN classification, that normalization is absolutely crucial. And you can go into this model up to 68.6% accuracy, which is not great, obviously, but based upon this data set, it is already going to give you a pretty adequate prediction with 68.6% whether a bottle of wine will have a number of quality or will have a certain level of quality. And imagine that if you're this big grocer and you're using this approach compared to if you're not using it at all, that this can make a world of difference when you're purchasing and making purchasing decisions. Good. So this is kind of an in-person walkthrough of the model. What I will start doing is I will quickly stop sharing the screen, and I will change it towards our studio window. So you will have a overview of exactly what the elements will be. So let me start sharing the screen. Good. I'm pretty sure that everyone is now able to see it. So what I've done for today's demo is that I've built a pre-built script so I can run through it quite quickly with all of you. Obviously, I will make this script available on the Big Data Framework website where you can just download it. So let me quickly run you through all of the steps, and then in case you have any questions, please feel free to put them into the question box as well. First thing to do is obviously you need to import all of the wines. So here you will see the data set. If I click on it, this is basically the Excel sheet that you're going to be seeing. And these are all of the different values and columns that I talked about earlier, which will have all of the elements. Note that the quality here is still given with a particular value, but then we're going to put that into different classes in a second. So note that for this particular example, we're only going to be using the red wines. So we're going to filter out or going to exclude all of the white wines and all of the columns that will have missing values, which is what I will show you right now. Then the third key part is that we are adding the quality labels, which was the first step that I explained. And here in this very simple example, you see that I mutate and add a particular column. And the way to do this is by labeling everything that's 6 to 7 as medium, everything that's 8 to 9 as good, and everything that's 10 as exceptional, and everything else is going to be rated as poor. This is just a very simple line of code that will add these quality labels. So if I do that, you will see that I have made a new data frame, which is called red wines label. So if I go back to my data frame, here you will see it. And if I open this, you will now see that at the end, there is this quality label that has been attached. And now every poor quality that's labeled as 5 is poor, 6 is medium, etc. So this is how that would work in practice. Then the next thing that I'm going to do is that I'm going to divide the training set into a training set and a data and a test set, which is what I will do here. For simplicity's sake, and in order to explain it easily, I will just take the first 1,000 bottles, which are going to be part of the training set, and the test set is going to be done with the remaining bottles. There are, I'm obviously aware, more random ways to do this. But because this is already a random data set, it doesn't really matter. And this way it's easy to explain it. So that's what we are doing right here. So now you will see that we have a test set and a training set. And the next key part that we're going to do is that we're going to start the training. And this is where we're going to be identifying the factors of true classifications within the training set, which is what I will run here. And now this is the moment that we actually start to use the KNN algorithm. So here we are using the classification package, as I mentioned before, and here we're using the KNN function. So basically what we're doing is that we're using the training sets, we're eliminating the columns 1, 13, and 14, as I mentioned before, and we're running that against the test set. So let me run that real quickly, and then you will see that the classification model will be built, and that's what we're seeing right here. So now we get towards step number 3, and this is where we can start to say something around the accuracy of our model. And we're going to get started with the default value, which is the value of k is 1. So in order to do that, what I will just do is I'm going to give compare the predicted class with the actual class, and now for a value of k is 1. I'm going to store that here so that we have access to it later onwards. So we do that. Here we can see that the value of the or the accuracy of the model is 0.5666%, which is 57% accuracy of our model, which is okay, but it's not great, of course. What we can then do is also make that confusion matrix. So I can just table the results as we've seen, and it's a very simple command to do that. And that will give us the same table that I showed you in the slide earlier with the values that should be there and that have different elements on the right forms of classification. Good. Where it becomes interesting is if we can, of course, start to see what is the best accuracy with using different values of k. The best way to do this is obviously to run a simulation for, let's say, all values of k. So moving from 0 or from 1 all the way, let's say, up to 1,000, and then optimizing for accuracy. However, in order to visualize it and in order to explain it for this webinar, I've just used a couple of values of k, which will start at 1 and will end at 15. And the reason I've done this is to show you this into the console and show you the results as well. So here, let's run the first one. Again, this should be the same result as what we've seen so far. And this is, again, is going to lead us towards 0.5666, which I've stored it in a value so we can compare it adequately. Let me run the second one independently as well. So if I'm increasing the value k is 1 towards k is 3, you will start to see that our accuracy is going up. Let me do that for the other values of k as well, for the sake of time. And if I run all of these, you will start to see different values with different levels of accuracy. So generally speaking, you will see that as k is going up towards 13, that we're getting towards a value of 60%. And interestingly enough, if we go beyond that, so we're moving towards k is 15, you will see that the accuracy is going to decline again. So very clearly in this particular model, there is an optimum value of k, which will be at k is 13 in this case. Okay, so the first step that you really need to do and need to understand is what is the value of k, what is the optimal value of K from an accuracy point of view. And by running different simulations, you can determine what the optimal value of K is going to be. The process that I've shown you right here is just for explanatory purposes, and obviously is not the ideal way to do it, because then you would run all values of K. But this is just to make sure that you get a bit of a better sense of how you could do this manually. The last key part that I showed you also as well is that normalizing the data will make a lot of difference. So in order to do that, let's first rerun the same version, but then with the default value of K is 1. And then I'm going to do that same thing, but then with the optimized value of K is 13. And let's look at the differences. So first of all, let me run all of this. So if we normalizing the data, is that we're already going to see an upgrade slightly for the normalized data. So remember that in our non-normalized version, the accuracy of K-1 is 0.5666, whereas we now see that if we normalize the data set, we're already going up towards 63%. So whether you're normalizing the data or not will have a very significant impact on the overall results of your classification algorithm. You can obviously do the same for K-13, and you will see that that will also help us move towards the final version, and that will lead us towards the 60% accuracy as well, and we're moving up towards 68. So now you will see, if I run the same confusion matrix, that the number of values that are correctly classified has gone significantly up. So normalizing in KNN algorithms is a very significant and important thing that you would need to think about. So both normalization in terms of data as well as optimizing the value of K is really the two crucial things that you would need to do as a data scientist. Good, let me go back to sharing the material that we have for today. So going back towards the lessons learned, think when you're applying the KNN algorithm, think about how do you optimize the value of K, and that's a very important thing that you would need to consider as a data scientist. And the second key part is applying the normalization and using normalized data to optimize it even further. Good. What I hoped that is that with this particular demonstration, you don't just have an overview of the theory around KNN, but that you also start to see some of the practical applications of how you could use this KNN algorithm in practice. And I would like you to also think about all of the different use cases that you could use this for. I have just obviously done this for bottles of wine. But think about all of the other different products and packages that are existing in the world that have all of the ingredients listed on food or on food containers. You could use the exact same classification algorithm that I showed you today in order to optimize all of these problems as well, and to already predict, without even having opened the package yet, what the quality of a certain package of food will be. I thought that this would be a very, very interesting concept to discuss, and also with some very, very practical use cases. Good. So in case you're interested, and I know that there is also going to be an additional Q&A, and I will come towards that in a second. But before I do that, hopefully in this big data webinar, I've inspired you to learn a little bit more around this. So in case you've become interested and you want to learn more, a couple of key steps that I would recommend doing. So first and foremost, note that most of the things that I discussed today are all part of the Enterprise Big Data Analyst program. So note that the Analyst program is completely free of charge. So you can download the free Enterprise Big Data guides. If you're more of a beginner, I would suggest starting with the professional level. If you feel that you're already a little bit more advanced, then the algorithms that I discussed today, as well as a number of others, are going to be outlined in the Big Data Analyst guide. So if you Google that or you go to the Big Data Framework website, you will be very easily able to download these books. In case you want to take your knowledge towards the next level, note that there's also an official certification around this. It's called the Enterprise Big Data Analyst Certification, and that is going to learn you around all of these crucial algorithms that exist and that you could apply in real-world situations. The certification is administered by APMG International in the UK. It's a global standard for certifications, and it's really, I would say, a good value add. The exam is obviously a paid version, so you could use the free study materials, but the exam itself is not free of charge. Two other things that are free of charge are the podcast. So I'm hosting a Big Data Talks podcast with a number of industry leaders. So I talk with people around what their favorite algorithms are and why. I've had speakers from all over the world, from the US, South Africa, Asia Pacific. So in case you're interested in that, please subscribe to the Big Data podcast. And last but not least, and also a very interesting part, if you found this webinar interesting, is the Big Data Days. So the Big Data Days is a 2-day conference. It's virtual, it's free of charge. So I strongly encourage you to sign up for that. Just Google Big Data Days or go to the Big Data website. And there you will find the speakers, the outline. There will be lots of sessions like I'm doing today, but then for 2 full days in a row. So those are some of the next steps that you could think about in case you are interested. Good, I'm right on time and still within the hour, so maybe good to answer a couple of questions that are coming in case you have any. In case you have any questions, please use the Q&A function, which you're seeing on the left hand of your screen, to see if there are any questions coming in. Good, let me have a quick look at whether there are any questions coming in. No, I don't see any unanswered questions. I see some people have already seen their questions answered. So I'm gonna give you 5 more seconds. No additional questions. So if that's the case, I hope it was very clear. I see a lot of claps going up, so I hope that that is really good and that you found this webinar useful. So in that case, I would like to thank everyone for their participation. I would like to thank everyone for being part of this webinar. I know there's a whole lot of people in this session, so thanks so much for joining. I hope you found it useful. I know it's a bit of a deep dive into these algorithms. And as a quick follow-up, I would be very interested to learn from all of you what would be big data algorithms that you would like to see explained in any of these next upcoming sessions. So if you have any thoughts or ideas on a particular algorithm that you would like me to explain in more detail, please let us know, and I would be happy to host a session specifically around this algorithm. The purpose of this series is to, in the next, every week, do a webinar which is around one specific algorithm in detail, so that by the end of the year, we have covered 40 or 50 of the most common algorithms that are being used within big data. So thank you so much for your time, everyone. I'm going to end the session right now. The session will be uploaded towards the YouTube channel as well as the website. Thanks so much for joining again, and I look forward to seeing you again in any of the other upcoming sessions. Thanks for your time today, and I hope to see you again soon.